So the topic that I'm going to start today is ear. We're going to do the anatomy of ear and we're going to start from here. This is the topic, ear. We're going to start with the parts of the ear. The first part is external ear. External ear. Then we have middle ear, which is also called tympanic cavity, and it is also called tympanum. Then the last part is internal ear, the innermost part, which is also called labyrinth. These are the three parts of the ear. Now let's talk about the external ear first. One part is called pinna, as we know. It is for the collection of sound waves, and it then projects them to external acoustic meatus. And the next part is the external acoustic meatus. Then there is the middle ear and the tympanic cavity and the tympanum, as we call it. Now it's the simple part. Now about the innermost part, that is the internal ear. We'll talk about two things. Further parts. We have the bony labyrinth and then the membranous labyrinth. Bony labyrinth can be divided into three parts: cochlea, vestibule, and the semicircular canal. And then let's talk about the parts of the membranous labyrinth: cochlear duct, saccule and utricle, and the semicircular canal. The cochlea, the bony labyrinth, is actually the shell of the membranous labyrinth. So you can actually write it down like this, that the cochlea is the shell of cochlear duct, vestibule is the shell of saccule and utricle, and semicircular canals, actually these are three, are the shell of these canals. About the external acoustic meatus. So we're starting from the medial, that is the inner 2/3. Third part is the bony part. This is the inner 2/3 part. It is the bony part and it is supplied by the auricular branch of fifth cranial nerve. The outer 1/3 is the cartilaginous part and it is supplied by the auricular branch of the 10th cranial nerve, which is the vagus nerve. So the other thing that you need to know is that skin of external acoustic meatus is strongly adherent with the underlying bone. So let's talk about the middle ear cavity. First we'll talk about the boundaries of the middle ear cavity. So the lateral wall of the middle ear cavity has a primary tympanic membrane, and the medial wall is is the labyrinthine wall. The inner aspect of the lateral wall has the attachment of malleus. The features of the medial wall: it is promontory because of cochlea. It separates middle ear from internal ear. It has fenestra vestibuli and fenestra cochlea. So the ear has two tympanic membranes. The first one is at junction between external and middle ear, and the second is at or you say the second is closing the fenestra cochlea. This is the striae tympani. This is how the shape is. So, and this is a striae vestibular, and this part is called helicotrum. So let's talk about the lateral wall. We know that malleus is attached with tympanic membrane at the lateral wall, and in close affinity there is cauda tympani nerve as well. I suggest that you open your books for where you have all the diagrams. That will help you a lot. Anyways, now about the floor. The floor is also called jugular wall because it has below it the internal jugular vein. Now the roof is called as tegmental wall. Through this, middle ear cavity is separated from the middle cranial fossa. This is the term otitis media. This is an infection. It is the infection of the middle ear cavity. It can also cause meningitis by eroding tegmental wall. Then there is the anterior wall, is also called carotid wall due to presence of internal carotid artery. Now the posterior wall, the posterior wall is also called mastoid wall. The two things that you need to know about this wall is that it has a facial canal. The facial canal has facial nerve which divides into greater petrosal nerve, nerve to stapes, and the cauda tympani nerve. It also has the opening that is the auditus to mastoid antrum. Now the communications of middle ear cavity. We're going to do two communications. Anteriorly, this wall will communicate with pharynx through the auditory tube, and posteriorly it can communicate with mastoid ear cells through auditus to the mastoid antrum. The parts of the middle ear cavity: tympanic cavity proper and the epitympanic recess. It is the part of tympanic cavity exactly opposite to the tympanic membrane. And the epitympanic recess contains an opening, auditus will be a better word, to the mastoid antrum. This part is the tympanic cavity. This is the tympanic cavity proper. This is the epitympanic recess, and this over here is the auditus to mastoid antrum. What is the function? If you want to write it down, you can. What is the function of the middle ear? The middle ear transfers mechanical energy to the cochlear tube. That is what is the function. The mechanical energy is the sound waves that come in, and they are transferred in the middle ear to the cochlear tube. All the sensations, general or special, of the body go to the thalamus, except olfaction, which relays to the cortex. This is important. Anyways, so moving forward, in the anterior wall, there is an opening which is called the auditory tube, through which middle ear cavity can communicate with pharynx. Through this, pharyngeal infection can enter middle ear cavity. So from this we know that otitis media can spread 4 ways. If it's laterally, it will rupture tympanic membrane and the pus will come out of the ear. If it's superiorly, it will cause meningitis or brown abscess. If it's posteriorly, then the mastoid air cells are involved, so it can cause mastoiditis. If inferiorly, it will erode internal jugular vein, causing venous thrombosis. Now let's talk about the internal ear. It has 2 parts, bony labyrinth and membranous labyrinth. It has cochlea, the bony labyrinth has cochlea, vestibule, and semicircular canal. The membranous labyrinth has a cochlear duct, saccule, utricle, semicircular canals. This part is the basilar membrane, and this part is the vestibular membrane. It's also called Reasoner's membrane. Internal ear has 3 parts, cochlea, vestibule, and 3 semicircular canals. I'm going to try to make a diagram of it. I'm really bad at drawing things, but whatever. So this part is the cochlea and this part is the vestibule. So this is the anterior semicircular canal and this is the posterior semicircular canal. And this is the lateral semicircular canal. This part is called ampulla. Each semicircular canal will open into the vestibule. There are 5 openings of semicircular canal into the vestibule. So let's count the openings. 1, 2, 3, 4, and this is the 5th one. Now I'm drawing the membranous labyrinth. This is the cochlear duct. This is the saccule. This is the semicircular duct. And this is the utricle. I'm not so good at the drawing, so I don't know exactly. You should actually open up your diagrams. There's a book of diagrams I forgot the name of. So yeah, you should look into that book or whatever textbook you have. You should look for the diagrams from that book and relate. Anyway, so look at this part. It has a attachment with the saccule and with the utricle. This is the endolymphatic sac, and this over here is the endolymphatic duct. Utricle and saccule are present in the vestibule. Organ of Corti is the modified form of cochlear duct. It's for hearing. Then there is maculae. This is the organ. It's a sensory receptor and it is the organ for static balance. Then there is cristae. It is the sensory receptor for kinetic balance. Modified form of ampulla of semicircular duct. Sensory information from macula and crista will be carried by vestibulocochlear nerve, and the sensory information from organ of Corti will be carried by cochlear component of vestibulocochlear component of the vestibulocochlear nerve. If there is a problem in the drainage of endolymph, then Meniere's disease. This is called the Meniere's disease. It is an episodic disease. There is kinnitus. There's a buzzing sound in the ear all the time, and then which later causes hearing loss. And there is ataxia. Bony and the membranous labyrinth are supplied by the labyrinthine artery. It is the branch of the basilar artery. Let's do the last part of ear, that is the mechanism of hearing. First, we have the sound waves at tympanic membrane. Then there is vibration at the ossicles. Stapedius will vibrate. Perilymph instri vestibuli will vibrate. Tentorial membrane will move the cilia of the hair cell, leading to the generation of action membrane potential in the outer and inner hair cells. This electrical energy will project to the cochlear component of vestibulocochlear nerve. This is then carried to the cochlear nuclei in the pons and then to the thalamus by auditory pathway and then to the primary auditory cortex.